In the oil and gas industry, where billions and billions of dollars are moved, the success or failure of a project often depends not on how big it is, but on something much more subtle, the sequence of its operations. It's not only what is done, but, and this is key, when it is done. Now we are going to unravel how the order of the factors does alter, and by a lot, the final product in this industry. Let's think about the exploration and production sector, or E&P. It's a world of very high capital intensity. Every decision, every movement of a drilling rig has a direct echo on the financial viability of the project. Here, the technical execution is not only engineering, it is literally the engine that drives profitability. To understand this puzzle well, we are going to follow a very clear route. First, we will get fully into the financial dilemma of the well. Then we will decipher the key equation between CapEx and OpEx and the enormous challenge of sequencing. Then we'll introduce an advanced solution called MEOSIP. And to close, we want the most important thing, the results, the real value it generates. Let's start at the heart of the matter. At the heart of any hydrocarbon exploitation project, there is a fundamental economic dilemma that defines whether or not it will be viable. And if, as you imagine, everything revolves around its wells. Look at these activities. Drilling and repairing wells are much more than a line item in a budget. They are the strategic axis that determines if an operation is competitive. Controlling these costs, which in the end are the majority of the investment, is the main challenge to maximize the value of an asset that has to be profitable for decades.
Now, to manage these costs, you first have to speak their language. And in this world, the financial language is based on two key concepts that define the entire strategy: CapEx and OpEx. The CapEx, or capital expenditure, represents the large initial investments in the development of a field. The CapEx activity par excellence is undoubtedly the drilling of a well. It corresponds to a heavy expense that is made once and is considered a productive asset that will generate income in the long term. And on the other hand, we have the OpEx, operating expenses. This is all it costs to keep the machinery running day by day. But here comes the interesting thing, the balance between the two. Sometimes a higher initial investment in CapEx with very high-quality equipment can drastically reduce the future OpEx because it minimizes failures and repairs that are very expensive. This table sums up the distinction perfectly. We see how the CapEx is building the asset, the OpEx is operating it. And then there are the famous workovers, or major repairs, which are hybrid. Sometimes they are capitalized if they add value and useful life to the asset. Okay, we already understand the types of costs, but now comes the really complex part. The game is not just about what you spend on, but when and how you spend it. Let's think that resources such as drilling equipment are finite and very expensive. Every decision to move a piece of equipment from one well to another becomes an optimization problem with many variables. An incorrect sequence can generate bottlenecks, and even worse, deferred production, that is, value that is destroyed. And this leads us to the question of the million, or well, of the billions. What is that golden sequence? The optimal sequence to squeeze the most out of the net present value, the famous NPV, which is the queen metric of profitability. How do we find that ideal route among millions of possible combinations? The answer, as in many other areas, lies in advanced analytics, and this is where a methodology specifically designed to solve this complex sequencing challenge comes into play.
MEOSIP is in essence a model whose objective is to find the perfect order to drill and repair wells. It seeks the maximum possible profitability, but always staying within the limits of the budget, and very important, with a level of risk that is acceptable. And well, what makes MEOSIP different? Its main power is in its stochastic approach. What does this mean? That does not assume that times and costs are going to be exact as on paper. On the contrary, it uses advanced simulations such as Monte Carlo to analyze thousands of possible scenarios of delay over costs and thus find a sequence that is robust in the face of real-world uncertainty. And be careful, it's not a technology that came out yesterday. In fact, it evolved from the Simulator of Optimal Sequence of Interventions to Wells, the SOSIW, SOEIP in Spanish, and has been tested and validated in super complex assets such as Cantarell in Chicontepec. Already has their flight hours, as they say. Very well. We have already seen the problem and the solution in theory. Now let's go to the good stuff, to what we all want to see. How does this translate into tangible value, hard cash? In this result, it says it all. In a real case study, the difference between the sequence that had originally been planned and the sequence that optimized the model was almost 1.1 billion pesos in net present value. That's the size of the economic impact of simply putting operations in the right order. And how do you arrive at such an impressive number? The secret is in the integration of data. The system does not see things separately. It consolidates economic information, production forecasts, risk models, equipment reliability data, all in a single engine. It's this 360-degree vision that allows you to find the sequence that is truly optimal. But the result is not just a cold number. It's an action plan that can be viewed through business intelligence dashboards. Planners can visualize exactly how oil and gas production will behave with the new sequence. This makes optimization a true strategic planning tool. And it's not just about production, it's also about managing uncertainty. The platform allows the risk of each intervention to be quantified and visualized. By understanding which projects are riskier, teams can redesign or prepare better for them, protecting the value of the entire portfolio.
Here we see another super powerful visual tool. This matrix compares the value of the Information Reliability Index, the Risk Index, technical and non-technical, against the NPV. This allows you to identify at a glance which interventions generate the most value from a multi-criteria analysis, helping to allocate capital in the smartest way possible. In summary, the benefits are crystal clear. It is about optimizing capital allocation, identifying and mitigating projects that do not look good, increasing the total value of the portfolio, and crucially, doing so with clear and real-time visibility of what is the optimal sequence to follow. There's a quote from the developers of the methodology that sums it up perfectly: "The first step towards the profitability of the movement of equipment." And the fact is that the optimization of the sequence is not a luxury, it is the starting point, the foundation to ensure the profitability of all assignments and contracts. And we close with this by posing a strategic question. In an environment with volatile pricing and constant pressure for efficiency, the ability to optimize the operational sequence is no longer a competitive advantage, it has become a necessity to survive.